Okay, here we are. We're back. This is section 5.1, and it's part 2. Part 1, we talked about subsets, and I think I got everything taken care of. And now we're going to go to the second part. We'll talk more about operations on sets. Before we do, just a couple items here. A Venn diagram is basically just a picture that shows, okay, get my pen going. It was working just a minute ago. It's a picture showing sets. I'm going to give you a couple examples here in a minute. You know, as they say, a picture's it's worth 1,000 words. I'll show you what I'm talking about. The universal set is going to be the set of all elements. Now that switches depending on what problem you're working with. For example, let's say we're talking about, you can compare a universal set with like taking a poll. So if you're taking a poll, you're going to say, you're going to take a poll of, let's say, all the students at the University of Indianapolis, and you're going to ask them a question. Doesn't matter, what it is. But the universal set would be the set of all students at the university. Okay, it doesn't include, other people that are around. It doesn't include anybody from, hold on, I'm trying to get organized here. There. Now I'm back. Doesn't include somebody might live in California or goes to school down at Southport High School down the street or something like that. It's just the people that I mentioned. So I said to begin with, it was a poll of the students of the University of Indianapolis. So I decided what my universal set was. Okay, now set operations. Okay, there's really 3 of them. There's intersection, that's not going to work anymore. Let's try another one. There's intersection, union, and complement. And for the intersection is another set. It's the set of all elements that are in both sets. This isn't going to work either. I got to switch one more time. Maybe time consuming. All elements that are in both sets. I say both sets, but later on we'll talk about 2, 3, 4 sets. So it's in all the sets at one time. Disjoint sets, I'm throwing this term here because I don't know where else to put it in, but disjoint sets means the sets do not intersect. Okay, so intersection, union. Union represents all elements that are in either or both sets. This is all wording. It makes perfect sense to me. For you, it sounds like I might be saying the same thing. When I show you some examples, then that'll clear everything up. And then the complement would be the elements not in a set. Okay, so here's some examples. First example, we're going to be given these sets. So my universal set will be the set 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Set A is 1, 3, 5, 7, 9, and B is 1, 2, 3, 4, 5. And I just made those up. Okay, so let's talk about the complement. When you see this symbol right in here, that means complement. Sometimes you'll hear math people say A prime, but it means the complement of A. And sometimes we'll write it like this. And to be honest, I can't remember what your book does. That's like A and then like an exponent of C. This is easier to type, so most of the books have went to this instead of that. So if I want the complement of A, complement, if you'll remember, means elements not in the set. So A is 1, 3, 5, 7, 9. So you ask yourself, what's missing? From the universal set, because these are the only numbers we're talking about, the ones that are missing, I'm missing a 2. So that's going to be 2. I'm missing a 4. I'm missing a 6. I'm missing an 8. And I'm missing a 10. So the complement is the set of all elements that are not in the original set. So if A is 1, 3, 5, 7, 9, its complement would be 2, 4, 6, 8, 10. So the word complement, you can imagine, let's say you had a couple, a guy and a girl, they've been dating, whatever, and people say, well, they complement each other. Well, that actually means that what one has, maybe the other one doesn't have, but when you put them together, they make a nice couple. Okay, they go well together. So that's where the word complement comes from. Okay, let's talk about the complement of B. That's a little better. So when I look at B, B's 1, 2, 3, 4, 5, and you say, well, what's missing? Well, in the universal set, it's 1 through 10. I've got 1 through 5. So the ones that would be missing would be 6, 7, 8, 9, 10. Okay, next up. A, and see this symbol right in here? That means intersect. So A intersect B. And you'll remember from what I set up on top, the intersections means it has to be in the two sets. So when I look at these two, I'm going to say, well, what do they have in common? Well, it looks like they both have a 1. So 1 is in the intersection. I see a 2 here, but there's no 2 here. So 2 is not in the intersection, but I see 3 and I see 5. So 1, 3, and 5 would be the intersection of the two sets. And we go here, that means union. So notice they're upside down each other. This one's easy to remember because U for union, that looks like a U, correct? And then when you look at this, that's an upside down U, or since we live in Indianapolis or we're here in Indianapolis, we talk about the Colts, that's like a horseshoe. Okay, A union B means, as you go back and you look at your two sets right in here, we're looking for the elements that are either in A, or they're in B, or they're in both. So right away, 1's in both, so that counts. 2's in B, so that's in the union. Even though it's not in A, it's in B, so it's in the union. 3 works. 4, 5, those guys are all in A. And then when I look back up to the top, 7 and 9. Okay. Now you remember back in algebra, you started out with real easy algebra problems like x plus 3 equals 7. Put it over here. If I said x plus 3 equals 7, you just subtract 3 from both sides, and you knew x was equal to 4. So that was a single operation problem. But what if I did this? What if I said 2 times x plus 4 equals 8. Well, you'd have to divide by 2. And then you'd subtract 4. So there was 2 operations. Well, it's kind of the same thing over here. I've got 2 operations. I've got intersection and I've got complement. Which one do you do first? Well, you always do the one on the inside first. So A intersect B. And here's what I do on this one. A intersect B, I already found that. It's up here. It was 1, 3, and 5. So I'm going to take the complement of that. So the complement of 1, 3, and 5, you're saying what's missing? Well, 2, 4, 6, and then the rest of them. These guys are all missing. Then the bottom one here, I'm going to take the union first and then the complement. So if I take the union of A and B was right here, so this is kind of long. I'm not even going to put the braces. I'm going to go 1, 2, 3, 4, 5, 7, 9. All I'm doing is copying these numbers down in here. And out of those, I'm taking the complement. So I'm saying what's missing. So I got 1, 2, 3, 4, 5, 6 is missing. 8's missing. 10's missing. And this would be my answer, and it is a set, so I'll put the braces around it. On all sets, you put braces. By the way, if you haven't seen this before, I know most of you guys would probably say, well, it's all the same thing, but let's just talk about this a second. Okay, when they're rounded, those are called parentheses. Okay, see if we can make this a little neater. These are called braces by showing up on the thing. Braces. And then sometimes they'll do this. These are called brackets. Kind of use those in matrices. So when we talk about sets, we use braces. Okay, just thought I'd point that out. Okay, so let's move on. We've got an understanding what the operations are. And, something else, I'll throw this out there also. There's a thing called, I'm probably misspelling this, Boolean algebra. When we think of algebra, we think of, equations and solving, and so basically we're working with numbers. And numbers, you have operations. The operations that we know are add, subtract, multiply, and divide. Well, Boolean algebra has to do with sets, and the operations are intersection, union, complement. Those are the same things I just went over. So in a way, I'm talking about Boolean algebra. I actually took a class one time. The whole semester is on Boolean algebra. And then later on, we got into logic and proof and things like that. Okay, let's move on. Okay, so if I went back, I want to show you something else before I move on. Sometimes, I'm going to go back to this problem right here. When I give you the information as sets, sometimes that's a little hard to visualize. So what we can do is we're going to make a picture of it. This is called a Venn diagram. And we start out with a rectangle, and inside that rectangle represents the universal set. So that means the numbers 1 through 10 are all in here, and all the other numbers are outside of that box. We've also got sets A and B, which are inside the universal set. And I'm going to draw it like this. Now, when you start filling in your numbers, because now we want to know where all the numbers are, you always start with the inside and work out. The intersection is this little overlap right in here. And those numbers are going to be 1, 3, and 5. Here's set A, here's set B. So set A was 1, 3, 5, 7, 9. I've got 1, 3, and 5. That means 7 and 9 go out in here. 7 and 9 are in A, but they're not in the intersection. And when you look at B, B was 1, 2, 3, 4, 5. So I've got 1, 3, 5. So that means 2 and 4 are over here. Now, there's still some numbers in the universal set that I haven't taken care of. I've taken care of 1, 2, 3, 4, 5. I need a 6. I need an 8. And I need a 10. Now, I put them down here, but I could put them anywhere in this little outside area as long as they're outside the circles. But that's what a Venn diagram would look like for this problem. Okay, so let's look at this. Here's a Venn diagram. Has nothing to do with the other problem. This is a new one. So you can see where I have labeled set U, set A, set B, and then I've got the numbers 1, 2, 3, 4, 5. So you can see there's only 5 numbers. So U will be the set 1, 2, 3, 4, and 5. I'm going to try to keep it simple. I'm not going to put the braces. Gets a little cluttered. This will help out. The set of elements for A, I see 1, 2, and 3. So what I'm doing on this one, I'm giving you the Venn diagram. You've got to figure out the sets. Set B, 3, 4, 5. The complement of A, if A is 1, 2, 3, and you look back, U is 1, 2, 3, 4, 5, the things that are missing are 4 and 5. The complement of B, B was 3, 4, 5, so I'm missing 1 and 2. The intersection of A and B, that's the overlap right in here, that's 3. That's the only thing there. And the union is everything that's in either an A or B or both. So that's 1, 2, 3, 4, 5. So the union is the same thing as a universal set. Okay. Let's take the same thing. We'll draw the set. You know, if you look real close, you'll see the MasterCard logo. That's where they got it from. Set A, set B. I know I've got 1, 2, 3, 4, 5. That's the same as above, but now I'm going to put some other number out here I'm going to call 6. Okay, now let's go through the same things. The universal set means everything inside the box. So I see 1, 2, 3, 4, 5, 6. Set A is still the same thing. 1, 2, and 3. Those are all the numbers in A. All the numbers in B is 3, 4, 5. The complement of A. So what numbers are not in A? 4, 5, and also 6. So this makes it a little bit different because now 6 is in here. The complement of B. So B is 3, 4, 5. So 1, 2, and 6 would be the complement. A intersect B. Still 3. A union B. 1, 2, 3, 4, 5. So it's all those guys. Not much change, but that's what happens when you have a number on the outside. Okay, one more page. So you could have more than 2 sets. In this case here, I've got 3. Okay, so the universal set looks like I've got 1 through 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Again, I'm going to leave off the braces. Set A, 1, 2, 5, 6, 7. And I do put these in order. Now, if you didn't put them in order, I probably would not mark it off, but I might not catch it either. It's just always good to put them in order. That way everybody's doing the same thing. Set B, I got 3, 4, 5, 6, and 8. Set C, 5, 7, 8, 9. A intersect B. A is this circle on the left. B is the circle on the right. The overlap for those two is 5 and 6. Anything in C really doesn't matter. It doesn't matter if it's in C or not. We're just talking about A and B on that. A union B. So that's anything in the 2 circles. So 1, 2, 3, 4, 5, 6, 7, 8. Next up, we're going to take A and C. Now, A is the one up here, and C is the one here, so we don't care about those. So the intersection, the overlap is 5 and 7. The union is everything that's in either one or both. So 1, 2, 5, 6, 7, 8, 9. 1, 2, 5, 6, 7, 8, 9. Now we're going to go B intersect C. So B's up here, C's down here. The overlap, 5 and 8. And B union C would be all of these guys, 3, 4, 5, 6, 7, 8, 9. Now we go here. This is A intersect B intersect C. So we're looking at the elements that are in all 3 at the same time. And there's only one of them, and that's right here, that 5. See how that's the overlap of all of them? And then A union B union C, that means it could be in A, it could be in B, it could be in C. As long as in at least one of them, it counts. We'll put these down here. So that's going to be 1, 2. I pick up 3 and 4 over here. 5 and 6 in the middle. 7, 8, and 9. Now we're going to get tricky. This says to take the intersection of A, B, and C, and then, notice how you got your little symbol out here, that's complement. Well, I've already done the intersection. The intersection is this one. It's 5. Okay? Put the answer up in here. So everything that's not 5 would be 1, 2, 3, 4. Then I'm going to go to 6, 7, 8, 9, and 10. Don't forget the 10 out there. Okay, then when I go below, this says A union B union C, which I already found the answer. I want the complement of this thing. So what's missing? The only thing missing is 10. Okay. Now I want to take the complement of A, intersect the complement of B. Now, I've already got those somewhere. No, I don't have them. Okay, so let's just do it this way. So the complement of A, let me do this. I want the complement of A intersect the complement of B. So the complement of A is 3, 4, 8, 9, 10. Okay? All that's complement of A. And I want to intersect that with the complement of B. The complement of B would be 1, 2, 7, 9, and 10. So if I want the intersection of those two, let's see, 1, 2, 3, 4, none of those are in there. 7, looks like 9 and 10. And that would be my answer. Okay, and then on this one, the difference is that's A complement union B complement. So I got the same numbers. I got 3, 4, 8, 9, 10. Take those guys, union with 1, 2, 7, 9, 10. So the union would be 1, 2, I got those over here, 3 and 4 is on the other one. Then you go to 7, 8, 9, 10. So it looks like it's everything but 5 and 6. Okay, last comment. Somewhere in your book, it starts talking about de Moivre's laws. De Moivre was a French mathematician. Obviously, from the name, it looks French, doesn't it? And they start talking about it, and there's 2 rules. Okay, don't worry about those. If you were doing set theory, it's beneficial to memorize those, because what happens, you find out the one on the left, that A complement intersect B complement, gives you the same answer as A union B, and then take the complement. Sometimes it's easier to do one than the other. We're not doing that much. There's no sense in you memorizing it. It'd probably screw you up more than anything else. So with that said, that finishes up section 5.1. See you in class.